yeah. Okay, so I start. Okay, so I plot the graph of y against x. Okay, so maybe you all stay with me, guys stay with me. Okay, so sometimes, okay, if you look at this graph, okay, I'm just going to borrow one of our friends' working. So I borrow this one. Okay, beautiful graph. Alright, so you notice that in this question, they did not tell you what is the recording. They don't tell you the x and y scale, so you have to determine by yourself. So when you are doing this, your y basically you need to put cents, and your x you need to put the number of days. Okay. So let me be a bit more bold now. If you look at this, right, what's the shape of the graph? Okay, actually it's just a straight line or curved line. Yeah, it's a straight line. Okay, so you can see this is a straight line. Okay. What is the y-intercept? 0, very good. It's just 0. And if I were to be a bit more bold, okay, remember this equation by right, if it's a straight line, can I say it's y equals to mx plus c? Right? Okay, then what is the c? The c will be 0. Very good. The c is 0. What is the gradient? 15. Very good. Okay, so can I safely say that the equation of this line is y equals to 15x? Cannot. So now you go back earlier. Remember the question in question 1.1, right? What did they say about y over x? They say that y over x is actually the rate. It's actually the rate. It's the same. Can you see it's the same question? They are using the same one in case you didn't see the reappearance. Season 2. Question 1.1 and 1.3 got the same table. It's all about the library file. So here, right, the rate, and you see the rate is a y over x, which is equals to 15. What do you notice about the rate and the gradient? What does the gradient give you? The rate. Yes. Okay. Closing your eyes here. Okay, good. Okay, so from here, basically, right, the rate gives you the gradient. The rate gives you the gradient. Oh, so it tells you that the increase in the fine for each additional book or book is overdue is a fine of 15 cents per day. The rate actually, the gradient gives you the rate. So far, okay? So in summary, if y is directly proportional to x, then the graph of y against x is a straight line that passes through the origin. Okay, if they are proportional, then we can also say that if y is directly proportional to x, we can also say that y is equals to kx. Okay, where k is a constant. And this is also one thing that we can assume. Y equals to kx. Kx plus 0. Right? Because it passed through the origin. There is no y-intercept. Okay, there is no y-intercept. Okay, so maybe now you need to look at the screen. You might need to copy what is on page 3 at the bottom of page 3. Okay, also again, this is also one of the things that you want to copy down in black. Okay, that if y is directly proportional to x, the graph is a straight line that passes through the origin. So do help me copy the one in black on the board as well. Y equals to kx. Y equals to kx. Then please try question 1.4 and 1.5 as your homework. Okay? Then we will continue tomorrow. Please try question 1.4 and 1.5 as your homework. So kx, kx. Okay, just think of kx. Okay? Okay, we have about 4 minutes more. You can try 1.4, 1.5. Yeah, I will let you go over as before. Big idea is this. Take note that, okay, if y equals to k, that's what I wrote on the board. Y over x can be equals to k. Y over x can be equals to k. A first. I go through A first. Okay, so if you look at A, 150 grams. Okay, there are two methods you can go about doing this. One is you can use the primary school way. Yeah, I sometimes I just okay. If not, I'll go through the proportionality way first. So if you count the sweets, if you let the sweets be represented by X, then the weight, the cost be represented by Y. Okay? X1 over Y1 is the same as X2 over Y2. You can use this. You can also write Y1 over X1 equals to Y2 over X2. You can also use this Y1 over Y2 equals to X1 over X2. You can also use this Y2 over Y1, X2 over X1. So I got quite a few questions from you all. Which one do I use? All works. All works. Okay? You just note that this is a rate. These two are rate. Okay? These two are ratio because we compare the same. The ratio will be the same, the rate will also be the same. Okay, ma? Can answer all? They are all good. If you don't believe, right, you just cross multiply. You all get the same thing. Okay, you cross multiply. So I'm just going to stick with one, okay? So I'm just going to stick with one. So x1 is let me call this x1 is the number of sweets, 50 grams, 50 grams cost $2.10. Then 380 grams cost how much? So I very humbly, sincerely and honestly, I just copy paste 380 over y2. What do you do next? This chapter very easy one, I assure you. This chapter is very easy one. Yeah, Aiden, what happened? Are you got questions? Don't have okay. Then you just copy control just cross multiply. Okay? Okay, right? And you should be able to get y2 to be 15.95. Okay, so this is the JH2 way, which we use the ratio and rate. Okay? So if I want to use primary school way, right? Primary school way is also very easy. Okay, so for example, the primary school way, right, in 50 grams of sweets, okay, you draw arrow, it's not equal, draw arrow. In 50 grams of sweets cost you $2.10. 1 gram of sweet cost you how much? $2.10 divided by 50. Then 380 grams cost how much? $2.10 over 50 multiplied by 30, which also give you 15.95. Okay? So both methods are okay. Both methods are acceptable. Okay, okay, so next one, 3/4 of a piece of metal has a mass of 15 kg. So first one, what you must do is you must what are you talking about? Try to listen, okay? Okay. So 3/4 of a piece of metal has a mass of 15. You identify two variables. One is the metal, one is the mass. Okay, one is the metal, one is the mass. What will the mass of 2/5 of the piece of metal be? If you're not very comfortable with the fraction, simply let it be erase. Still have erase. Okay. You can let, for example, let the metal be x. Okay? So 3/4, for example, then you have x1 is 3 over 4, and y1 is 15. Now if x2 is 2 over 5, what is y2 equals to? Okay, so from here we can also form the equation. So y2 over x2 equals y1 over x1. Okay, and then from here, just cross multiply 3/4 y2 equals to 2 over 5 times 15. Okay, ma? Can I? Nikhil, okay? Okay, so with that, let's come in to look at this is B. Answer should be 8. Okay, the answer should be 8. The answer should be 8. Have you all done B? No, haven't done B, huh? Who have not done B yet? Raise your hand. After that, y1 can be equals to $2.10. y2 can be the cost for 380 gram sweets. It can be the cost. Okay, so from here, right, we form the derivative. You should be able to solve for the question. Dollars. Cost y. Then we can call this x1. We can call this y1. Similarly, I can call this x2. And I'm supposed to find what is y2. Okay? So if we form the equation, okay, alright, for rate, we take y1 over x1. It should be the same as y2 over x2. X1 represents 50 grams, Y1 represents $2.10, X2 represents 380 grams, Y2 will represent the cost for 380 grams. Isn't easy, Jeremy? Correct. This is you, right? Okay, so using tables, if y is directly proportional to x, then y1 over x1 is the same as y2 over x2, or x1 over x2 is the same as y1 over y2. So we will go through something what we call proportion. Okay? So you see, okay, in Singapore, if we borrow books, who's clean? Huh? W? Oh, okay. In Singapore, if we borrow books from the library and we are late in paying the books, the so fast, you run. Okay, the table below shows the fine for an overdue book. Okay, so you just take a look at it. Okay, if you look at x as the number of days and y as the fine, right? If 1 day I'm fined 15 cents, 2 days I'm fined 30 cents. Okay, so it makes sense because I'm multiplying by the number of days, right? What do you see about what we call the rate? So the rate here, you observe 15 divided by 1. What's the rate? The rate is 15 cents per day. So you notice that if you take y2 over x2, y3 over x3, right, the rate is always a constant. So x1 over y1, just observe x1 equals to 1, y1 equals to 15. If you take y1 over x1, that's equals to 15. x2 equals to 2, y2 equals to 30. y2 over x2, that's also equals to 15. So this is what we mean by that I have y is directly proportional to x, y over x will give you a k. Okay, this k here, right, this is our k. Is it recording? I make it bigger so you can see how.
Playing music, you help me pause.
Try to hurry a bit, okay? Try to hurry a bit, huh? Slowly, okay, you're still looking, okay, sorry, okay. So if you look at question 1.1, right, you notice that if I treat x as the number of days, right, and y as the fine, right? x1, y1 over x1, y2 over x2, it always gives you a constant. The constant is 15. And this is actually what we call the rate. This is what we call the rate. Right? So y1 over x1, this in general, y over x, we call this a rate. Okay, whereas between two different quantities, okay, we can also call it a proportionality constant. So you notice that no matter what I do, whichever x I take is always equal to the same k. K is always equal to the same constant. Right? This is what we call a rate. Okay, a rate is a constant. Okay, it's at the bottom of page 1. So if two quantities x and y have the following relationship, as x increases, y increases proportionally, x decreases, y decreases proportionally, we can say that y is directly proportional to x. Okay? Okay, example, maybe you talk about working. Let's say you go outside, maybe, I don't know, at your age, when I was 8, maybe I go and work in a bubble tea shop, or work Mr. Coconut, or Koi. Okay, so for every hour you work, you earn more money, right? Right? So your hours and your salary goes up proportionally. Okay, you go for training, the more you train, the faster your timings, or the better your jump shots. Okay, or the higher the more games you win. Right? So it's proportional. In life, of course, also simple lah. Okay, but I mean, generally, your luck and your hard work, okay, as your hard work increases, you also tend to win more games. Okay, so these are proportional examples of real life proportion. Okay, examples of real life proportion. Okay, so y is directly proportional to x. So when we compare a difference between rate and ratio, okay, a ratio compares two quantities of the same kind. Meaning, if you see this is y over x, right? So this one is a rate. Whereas if you compare ratio, okay, maybe x1 over x2. x1 over x2, we call this a ratio. Okay, this one is like internal competition. We compare two quantities of the same kind. Okay, so take note, the same kind is called rate. So the same kind is called ratio. Okay, is it meant to be off? I see the switch on. Yeah. Hey, it's on. Okay, so a rate rate compares two or more quantities of different kinds. Okay, so sometimes they may ask you for the rate versus ratio. Take note, this is rate, two different kinds. This one is ratio. We compare same kind. Okay, okay. So very quickly, we look at question 1.2.